In lesson 4.2, we're going to look at calculating and classifying slope. Now, slope is the same exact thing as rate of change. It's only used for graphs instead of tables. So if we look at the first graph, we're going to try to find the slope from one point to the next. So remember, slope is kind of like our rate of change. So we want to find out how do we get from the first point to the second point and what that change is. Now remember, when we read our graphs, we always read them from left to right. So you want to start at the leftmost point, which is right here. And you're basically going to, give that point a set of instructions by using what's called the rise over the run. Now, when we think of rise, that's normally a vertical change, so it's either going up or down first. Now, for the run, it's generally a horizontal movement, so we're either going to go left or right. So let's start at the first point. Now, we need to either go up or down, like we said. So we're going to rise a total of 1, 2, 3 points. Now, if that 3 points goes up, we know that's going to be a positive 3. So once we get to that point, we now want to figure out how do we get to our next point? Do we go left or do we go right? So when we run, we're going to run once, twice, 3 times, 4 times, 5 times, 6 times to the right. And remember, if we move 6 to the right along the x-axis, that's going to be a positive 6. Now we want to reduce this, so divide top and bottom by 3. And you'll be left with 1/2, which is your slope. Now, if you didn't go up, let's say you went down 3, that's going to be negative 3. Now, if you went to the left along your x-axis, that's also going to be negative. So you want to keep an eye out in case that ever happens. Now, if we don't have a graph, we can have 2 points that are on the graph. So we're going to have to use the slope formula, which is y2 minus y1 over x2 minus x1. Now, when we go to label these, this is your first x, this is your first y, this is going to be your second x, and this is going to be your second y. So let's plug it in using the formula. I'm going to have 1 minus a negative 2, and I put in parentheses so I don't confuse myself. And then I get 4, and I subtract it by negative 2 as well. And again, put in parentheses so you don't confuse yourself. When you're subtracting, you want to do keep, change, change. So this is really 1 plus 2, which is 3. And this is 4 plus 2, which is 6. Again, you reduce it, and you should get 1/2. When you get down to vertical and horizontal lines, it's a little bit different. All right, we're still going to think about the rise over the run. But in this scenario, your slope is a little bit different. You can't rise, so you can't go up or down. So no matter what happens, your rise is always going to be 0. And to get to your next point, it's going to be some number, but we don't know what that number is yet. So no matter what happens, you're going to have 0 divided by some number. So all horizontal lines have a slope of 0. You don't even have to calculate it. When you look at vertical lines, it's the opposite. So you can move up or down. So we don't know yet, so that's just going to be a random number. And you can't move left or right. So that's going to be 0. Now, no matter what number you have, if you divide it by 0, on your calculator, you may get something that says error. You may get something that says negative infinity. That just means it's undefined. So we can't define our slope. So again, you don't have to do the math here when you have a vertical line. You're just going to characterize it as being undefined slope. And that's pretty much it.